Good day everyone. Me and my group mates will talk about foundation, an important part of building that makes a structure safe and stable. Foundations are critical structural elements that transfer loads from the building to the ground. They ensure structural stability, resist environmental forces, and prevent uneven settlement. Foundation designs are based on soil condition, building load, and climate and budget. So the main purpose of a foundation is to transfer load safely to the ground, prevent settlement, resist wind and earthquake forces, provide stable base for construction. Staking and framing system. Staking is the laying out of the building plan to the ground, while the framing system is the internal skeleton, mostly made of wood, steel, or concrete that gives shape and support to the building. Next is the types of foundation. So there's two types of foundation. First is the shallow foundation, or used when good load-bearing soil is close to the surface. Examples are strip foundation, pad foundation, and mat foundation. Next is the deep foundation, or used when surface soil is weak or load requirements are high. Examples are pile foundation and caisson foundation. First is strip foundations, a type of foundation used to provide support for linear structures like walls or columns, used where good load-bearing soil is close to the surface. Next is pad foundation, a type of foundation that is consisting of a concrete block or pad that supports a single point load, such as structural column, by spreading the load over a wider area of soil or rock. It could also be a continuous concrete strip beneath the load-bearing walls. Next is mat foundation, a type of foundation that is large, continuous, reinforced concrete slab that covers the entire footprint of a building, distributing the structural's total weight over a large area to support all its columns and walls. Pile foundation, a type of deep foundation consisting of long, slender columns made of materials like concrete or steel that are driven or formed into the ground to transfer structural load to deeper, stronger soil or rock layers. And lastly, caisson foundation, a type of deep foundation that uses a watertight prefabricated box or cylinder sunk into the ground and filled with concrete to form a stable base for structures like bridge, piers, or high-rise buildings, especially those built underwater or in challenging soil conditions.
So, I'm going to talk about types of footings. Footings are foundations that transfer building loads to the soil and include types like isolated footing, strip footing, combined footing or raft, step, and pile footings. The choice of footing depends on the building's weight, soil conditions, and the structure type. Isolated footing. So, an isolated footing, also known as a pad footing or spread footing, is a shallow foundation element that supports the load of a single column or separate wall, transferring its concentrated load to the soil below. So, isolated footing supports a single column, and its shape is square, rectangular, or circular, and it is used for light to moderate loads on firm soil. For example, residences or houses. Combined footing. A combined footing is a single continuous concrete foundation element that supports two or more closely spaced columns or walls. It is used when individual isolated footing would overlap due to the close proximity of columns or a low soil bearing capacity. So, combined footing supports two or more columns that are close together, and it has a rectangular or trapezoidal in shape, and it is used when space is limited or columns are near property lines. Continuous footing. A continuous footing, also known as a strip or wall footing, is a type of shallow foundation that serves as a continuous strip of concrete to distribute the weight of the structure evenly over a large area of ground, typically supporting a row of columns as a load bearing wall. So, continuous footing or strip footing is a long footing under multiple columns or entire wall. It distributes loads along the length, and it's also used for load bearing walls. Strap footing. A strap footing is a foundation system connecting two or more individual column footings with a rigid concrete beam called a strap beam. Strap footing or cantilever beam transfers unbalanced load from one footing to another, and it is used near boundaries to avoid eccentric loading. Raft and mat footing refer to the same type of foundation, a large continuous concrete slab that covers the entire footprint of a building, spreading its load over a wide area of soil. So, raft or mat footing distributes loads across a large area, and it is ideal for poor or loose soils. Pile cap footing. So, a pile cap footing is a fixed slab resting on piles. It transfers load from superstructure to deep piles, and it is commonly used in deep foundations.
Factors affecting foundation and footing choice. There are five, and it's soil bearing capacity, type and magnitude of loads, depth of groundwater, building design and layout, and lastly, cost and construction feasibility.
Now, let's talk about common foundation issues. There are a lot of foundation issues, but we will tackle more on the common ones like uneven or excessive settlement, the water intrusion or poor drainage, the foundation cracks due to soil movement, and the inadequate compaction or materials. The uneven or excessive settlement happens when the soil under the building compresses unevenly, causing tilting or cracks in walls and floors. Next is the water intrusion or poor drainage. The water around the foundation can weaken the soil, cause leaks, or damage structural materials. Next is the foundation cracks due to soil movement. The expansive soil, like clay, swell when wet and shrink when dry, putting pressure on the foundation. Lastly is the inadequate compaction or materials. Poorly compacted soil or low quality materials can reduce the strength and stability. We can do some things to prevent those foundation issues like detailed site investigation, correct foundation type selection, proper drainage and waterproofing, and high quality construction materials and supervision. First is the detailed site investigation. We need to study the soil conditions before construction to avoid surprises later. Next is the correct foundation type selection. We need to match foundation design with soil, type, load, and groundwater conditions. Next is the proper drainage and waterproofing. We need to install systems to divert water away and protect against moisture damage. And lastly, the high quality construction materials and supervision. We need to use durable materials and ensure skilled workmanship for long lasting performance.
So in this slide, I'll be talking about schedule of footing. So for on the upper part of the drawing, we have a table called Schedule of Square Footings. This table summarizes the important details for each footing. Marked F1, F2, F3, F4, these are different types of footing used depending on the size of the column and the load it will carry. Next is the depth of excavation. All footings here are excavated to a depth of 1000 mm or 1 meter below the ground. Next is the footing dimensions. or basically the width, length, and thickness. For F1 is 1 meter by 1 meter with a thickness of 250 millimeter. Next is the footing 2 is 1.3 by 1.3 meters, same 250 mm thick. For footing 3 is 1.5 meters by 1.5 meters. For footing 4 is 1.6 meters by 1.6 meters and slightly thicker at 300 millimeters. Rebar size reinforcements all use 16 millimeter diameter rebars. This table also shows how many rebars are placed in the XY directions at the bottom matting of the footing. So for footing 1 has 5 bars in each directions. For footing 2, 6 bars in each direction. For footing 3, 7 bars in each directions. For footing 4 has 8 bars in each direction. This means that the footing gets larger, it also needs more steel reinforcement to handle greater loads. Next is below the table we have the section views of the footing. This shows us the footing in the cross section, meaning as we slice it to see what's inside. The excavation depth is shown with the footings placed 1 meter below the natural ground line or the NGL. On top of the footing, you can see the vertical column bars that will be connected to the column above. Around the column bars, there are 10 mm column ties for confinement. This section also shows the matting bars at the bottom of the footing, which are the horizontal bars for both direction. So next is plan. At the bottom part, we have the plan views of the footing. This is the view from the top looking down at the reinforcement layout. This line shows the arrangement of rebars in both x and y direction. And for the conclusion is, uh, in summary, this drawing provides the complete details of the square footings, dimension, excavation, depth, reinforcement, and construction notes. These are critical for safety and stability of the building since foundation is what carries the entire load of the structure. Without proper footing design, building would be at risk of settlement or even collapse.
So, to conclude everything that has been said, foundations and footing form the essential base of any structure. A well designed foundation ensures a structural safety, longevity, and resistance to environmental forces. Selection depends on site condition, structural loads, and construction constraints. Understanding different types of foundation and footing is vital for effective building design. Thank you.